In number 13b, we're asked to find if the solution has a system, and if so, where it is. So the first thing you want to look for is, does it have a solution? Because if it doesn't, you're kind of already done, right? So look for your coincident, look for your parallel planes. We don't notice any scalar multiples right off the bat, so I'm guessing that's not true. Next thing we want to look for is there any linear combinations here? And it's a little tricky to see maybe, but if you take equation 1 and you add 3 times equation number 2, you actually get equation number 3, which means we have the situation where these 3 things are all meeting along a line, which means we won't get an infinite number of solutions. So we're going to have to use a parameter. So we're going to pick any 2 equations we want to solve. So let's take the top one, number 1, and let's take the second one, x plus y minus 2z equals 1. And we can add them because the y's are opposite signs. We'll get 3x minus z equals negative 2. And because it's a line, we got to make a parameter. So let's make x equal t. Now the reason I'm using x is it is part of this previous equation, right? So I can very quickly say, well, 3t minus z equals 2, or 3t minus 2 equals z. Now I've got 2 parameters. I can go back to one of my initial equations. Let's take equation number 2, if you will, and replace x and z now. And I'll get t plus y minus 2z's. Each z is worth 3t minus 2 equals 1. So we'll get t plus y minus 60, expand your brackets, multiply them out, plus 4 equals 1. In other words, y equals 1 minus t plus 60 minus 4, or y equals 5t minus 3, or negative 3 plus 5t. Okay. And, oh, you know what? No, that's right. Actually, you know what? There is a mistake in here. Sorry, guys. I have a little fix here, okay? It should have been negative 2 back in. I made a little typo here. So it's a plus 2, a plus 2, minus 4, plus 4. And that's going to be a plus 5. Okay, so the line that these things meet along, we would need to write a vector equation for it. Didn't ask us for it, but they need to write a vector equation. We'd have 0 for x, we'd have a y value of 5, a z value of 2, and the parametric part would be 1, y is 5, and z is 3. Here's the line that they meet along. Okay,